Okay, I went through and touched up a lot of these solder joints that looked kind of old and in some cases cracked a little bit. Try to eliminate some of the noises and things that this amp has. Next thing I want to do is go through and clean the potentiometers, and some of my other videos on scratchy pots, you've seen this done before, and I'm not going to show this on all of them, but what I do is I use a contact cleaner that has a lubricant in it, contact cleaner and lubricant on these potentiometers. Made myself a little extension onto my nozzle so that I can get down where I need to get, and then just spray it in each one. Spray a little bit in there, and then work them back and forth at least 5 or 6 times. And if they're stiff, it'll free them up. If they're dirty, it will clean the dirt out of it. So, get the next one here. Can's getting a little low. Okay, so I'm going to go through and do all those. Well, the capacitors that I ordered have come in, and I'm ready to replace the old ones. The originals that were in there were two 70 microfarad 350 volt DC, and then there were 3 20 microfarad at 500 volt DC. And usually what I've done on a lot of this kind of repair is to use the Sprague Atom capacitors, which are very close to the same size as the originals. They fit in there, and Sprague has had a very good reputation for many years, but they're very expensive as a downside. You can use some other brands of capacitors, and some of them are certainly acceptable. And what I've chosen to use in this repair, and the quality of the repair will be good and the capacitors will last a long time and do what they're supposed to do, is use the Illinois brand. It's a very common, certainly less expensive capacitor, and the size, as you can see, is much smaller than the ones that are currently in there. But I'm using, in place of the 70 microfarads, I'm going to use an 80, and it's rated at 450 volts instead of the 350 original. And then for the 22 microfarad at 500 volts DC, so a little bit more capacitance, but rated at the same voltage rating. So one thing I was talking about when I took this apart was how there's a rubber weather stripping that is put in the lid here, glued in. I've removed that already, and that's just to hold these old capacitors down from moving. But it was very sticky and oily, and what I realized afterwards was that actually some material from the old capacitors had leaked out and essentially melted the rubber in there. So that's why that oily substance was in there that came from the capacitors. So I'm going to go ahead and the first thing you need to do is to either remember the polarity of these capacitors. For instance, on this one you can see that it says plus, that end is the positive end. On this one the positive end is down here, and then on this 20 microfarad positive is down here, positive is down here, and positive is down here. And since these are the original capacitors, I don't have any doubt that these are in there in the correct polarity. But for amps that have had capacitors replaced before, particularly if they're damaged, I like to check them. I would actually power the amp up and measure, put a voltmeter across here, plus to the plus end, minus to the minus, and make sure it says plus on the meter. If it says minus, then the capacitor is actually, it's in there in reverse, it's backwards. And I've got a picture someplace of what happens when you put a capacitor, what can happen if you put a filter capacitor in reverse polarity. They kind of blow up. And I've got a still picture somewhere that I'll try to remember to include in the video for you to see. So the next thing I'm going to do is note the orientation as far as polarity of these capacitors. Take each one out one at a time and solder in the new ones. I'm not going to demonstrate that. That's going to require two hands, and if you're watching this, you either know or can figure out how to solder them in. At this point, I've taken the old capacitors out. What I did was I just took a pair of small wire cutters and just clipped the leads on each end of the capacitor and lifted them out. I'm not showing it as I do it because I'm filming this by myself and I really need two hands to do this. So this is the point now, and then I'm ready to solder in the new capacitors. Okay, I got the first one soldered in. One thing I want to point out on these capacitors, they don't mark the positive end of the capacitor. They have a group of arrows here and a minus sign showing that this is the negative end. So by default, you know, the other end is the positive end. So just different brands mark them a little bit differently. As far as soldering it in, just a matter of getting the leads the right length. Try to kind of center the capacitor up. And then make sure you've got, I clipped all the old ones off, and so the ones that I can heat up the solder and pull out the little stub that's left in there. Put the new one in there and solder it down. On this end here, it's tight, the wires are closed, so you have to kind of pull them up out of the way and be careful. You do not want to melt the insulation on these. If you can't do it, can't get to it very well, you could come down here and take these wires loose temporarily and just pull them back and then solder it, but I don't do that. I usually can just get enough slack in the wire to pull it up away from the solder joint so that the heat of the solder, when you solder that joint, doesn't melt the insulation. You don't want to provide another path to this capacitor with these conductors. So I'm going to go through and do the rest of them. Alright, all 5 capacitors are now soldered in, and got checked and double checked the polarity to make sure that I have those correct. And so the next step is just to take the cover and get some more weather stripping, which I'll pad up the top of the cover to set the weather stripping right down on top of these capacitors, just to hold them firm where they're not moving around a lot as the amp is moved around and as it vibrates, just to keep that solder from getting stressed and broken. So that's basically the capacitors that we're going to replace from this side of the chassis. There are a couple that I want to replace from the other side of the chassis also. Alright, to go ahead and finish up, I cleaned out the bottom of the lid here to get that oily stuff out, and then I put in a couple of pieces of foam rubber weather stripping to hold down these capacitors with the lid, just to kind of make it the same way that it was before. I don't think you'd go too far wrong by not putting that in there, because these capacitors are a lot smaller and lighter than the original ones that are in there, but just to make it as robust as the original one was, I elected to go ahead and put it back the way it was. So now there's some resistance to that foam rubber, so you can tell it's nice and tight when it's pulled down on there. So I'll go ahead and screw that down, and then we'll turn it over and move on to the next step. Just for the fun of it, since I had these old capacitors out of the circuit now, I decided to test each one of them to see what the capacitance value is currently on these capacitors, and I'll show you pluses at the top there. Working one-handed here, so connect the red to the positive lead, and then if you can see, it's reading about 85 microfarads instead of the 70 it's rated, that's no big deal. That's close to tolerance, maybe intolerance. But the interesting thing is that one of them, of these 20, I think this one is it, one of these that are supposed to be 20 microfarads reads a big 0. So obviously even beyond being old, worn out, and subject to failure in the future, one of these capacitors is already failed. It has no capacitance. So the amp is going to be certainly quieter, less hum or noise probably from just replacing that one capacitor. For the capacitors on the underside of the chassis, I'm going to replace these two bias voltage capacitors. And then I'm going to check the grid bypass, these bypass resistors, and replace as required. They're electrolytics also, but they're not the same type and not prone to leaking, and so I'll lift one lead on each one so that I can accurately measure the capacitance of each one of these white bypass capacitors, and if they're out of tolerance, then I'll replace the ones that need to be replaced. Okay, I replaced these two electrolytic capacitors that are in the bias voltage circuit, and in addition, as I said I was going to, I went through and I lifted one lead of all these bypass capacitors and tested them, and I found 3 of them out of range. These are 25 microfarad capacitors. Usually capacitors have a 20% tolerance, so that would mean it could be as high as 30 and still be within range. These were 36 to 40 microfarads, so I went ahead and changed out the ones that were out of range. The new ones are Sprague capacitors, and they all test right at 25 microfarads. So in addition, while I was at it, I went ahead and tested these screen grid resistors that are 470 ohms, and there's one on each of the 6L6 tubes, the power tube sockets, and they are all okay also. So now I'm going to do a couple more things. We've cleaned the pots. We need to clean the jacks, and I show that on one of my other videos about cleaning jacks, also cleaning pots, if you want to check those videos out. But I'm going to turn the chassis over and do a couple of other things. We're also going to check the tube amp bias, and again, I have a video on biasing tube amps, so I'm not going to go through that whole process, but I am going to check it. Another thing I like to do on tube amps, especially ones that haven't been worked on in a while, is to pull out each tube and examine the tube socket and see if nothing broken, none of the contacts are broken in there, and also to look at each tube at the pins if they seem straight and clean. And what I'll do is I have a device here. It's a pin straightener, and it serves 2 functions. If any of the pins are bent, it will straighten them out, but it also, when you stick the pins down in there and pull them out a few times, it also kind of cleans up the pins a little bit, takes some of the corrosion off of them. So I like to do that. And then finally, I like to take a little just plain contact cleaner, this time one that doesn't have any lubricant in it, and spray it down into the contacts of the tube socket, and then plug the tube back in, getting it oriented right. And pull it up, push it in a couple of times to clean out the tube socket. I'll do that for each of these preamp tubes, and then power tubes also. Alright, I just checked the bias on the power tubes, these 6L6s here, and they were setting at about ranging from 16 to 19 milliamps at idle, and there's 475 volts plate voltage, so to me, looking at my charts, that's a bit low. So I set them all up to, on average, about 30 milliamps, which seems like a pretty good conservative setting for this amp in that voltage level. So the tubes are pretty much taken care of. I think we've done everything that we wanted to do with the amp so far. We've checked it over, changed out the capacitors that needed to be changed, corrected some bad solder joints, taken some loose parts that were in the chassis out, cleaned the pots, cleaned the jacks, and it's pretty much also fixed the reverb, pretty much ready to put back into the case and give it a final test here.